Hello guys, I'm Ashish here. You can see a bunch of things here. Set of jumper wires, a USB D type cable, some more wires. We have a custom made Arduino board with LED pin on pin number 9 instead of pin 13, so we can perform fade action by default sketches, as well as we can change the pin 13 to pin 9, and we can run on a blink sketch as well, so it's really convenient here. Well, we don't have a FTDI on board. You can set the USB to serial converter IC like CH134 and all that, FTDI CP2102. Well, this is the 705 voltage regulator. It's supposed to be there because I have to run applications through 12 volts or more through 17 volts sometimes, so it's necessary. Well, these are pinout. This is the ISP header which I'm using in this demonstration, or as a tutorial we say most of the time. Okay, and this is a reset button. There's nothing more on board. It's bare minimum board made from scratch. Well, this is a Arduino Pro Mini. It was bought from eBay, I think Amazon or eBay, I don't remember really. Well, this is so tiny that it fits on my little pinky finger. Well, that's so small, right? This doesn't belong to me, but I have it for now, so I'll be using it for this tutorial. Okay, well, features about this: it comes in a variant of I know its focus is really bad for now. It comes in a variant of like 16 megahertz, 20 megahertz, 5 volts, 3 volts altogether. 5 volts, 3 volts can be all together, and 16 megahertz, 20 megahertz, they can be sometime really different in different products. For this one I have is using a 16 megahertz crystal on board, and it is self-regulating 5 volts and 313 volts. Well, that's not gonna bother for us. Well, now the next is we don't have an onboard serial converter, so we have a USB to serial converter based on CP2102. Okay, and this was a custom made DigiSpark with a micronucleus bootloader. Well, I made pin headers on it so that if I in future require to connect other boards through USB circuit, which is over here, made over here, we can just plug off this, pick up this IC and connect the header directly to AVM microcontroller from VUSB projects. So this is the board we are going to use for the VUSB interfacing. That is for this time for us we have firmware modified to be to function the Arduino here as a USB ASP programmer, and this is gonna help for that. Well, you can have a custom made like say, what do you call that thing? Yeah, I'm sorry, what's that? The shield, a kind of shield, yeah. So you can have a small Pro Mini shield built from scratch like this kind of boards, and you can mount it on just using some kind of USB cable connector and this minimum circuit. And yes, for the circuit, of course, you must know that you cannot have any kind of minor short circuits anywhere else throughout this connection, because these connections are really sensitive, and if you don't give a proper interrupt feedback to the USB port, what happens is you seem to have an unrecognized device. It happens most of the time for this reason. Most of the time the firmware can be damaged and it happens as well, but this is the most of the time why it happens. So you see properly how much spacing is made. I have scratched off so that even no flux stays in between to make it conductive somehow anyway. So it has been really made short circuit resistance from each track to track. So remember, this thing is really important while making this circuit. And yes, of course, what's one more thing I should make you sure for. The Zener diode should be rated 3.6 volt or a little more than that, is 3.9 volts, but should not go below this or above this, because it's gonna regulate this D plus and D minus pin outs to exactly 3.5 around 3.6 volts, and if it goes beyond that, interrupt will deny to recognize the device. So there are many tricks here why we use this diodes, and really important in the VUSB circuit. So all you will need is two Zener diode rated 3.6 volt, which is in the circuit provided by VUSB, and a 68 ohm resistor parallelly on D plus and D minus, and a 2.2k resistor to pull up the pin high so the interrupt can spool back, and when it's not spooling it back, it will see it as high and device gets connected. It's a pull-up resistor basically for device detection. Well, now what we are gonna do is get this get this IC off. Sorry, I'm using only one hand, so I'll have to keep it somewhere. Okay, so we will rip out the IC first. Okay, it's really dangerous to pull this IC like this because you can damage the pins. You have to be really careful for that. Let's see. The IC is over here. I am using two of my legs. It's really funny. Well, we have ripped up the IC, and now the board is bare to be used as a VUSB interfacing circuit. Well, for now I have already programmed in the firmware for Arduino as a USB ASP. Well, what will happen exactly it's gonna do is like first the Arduino bootloader will start, and it will look for the firmware. It will wait for the time delay to a signal to arrive and a programming signal to be activated, and if it goes beyond time and its time's out, then it will load the firmware inside. So what we have done, we have uploaded a raw sketch, a raw hex file we compiled in of course WinAVR, not in Arduino, WinAVR environment using AVR GCC compiler, and then we uploaded that hex file directly onto this chip using the Arduino bootloader, of course, because we are not going to modify anything in the Arduino. We are sticking to the plan that we are going to use Arduino as the USB ASP programmer, not a modified Arduino. So this is not at all a modified Arduino. This is really genuine Arduino with all genuine firmwares. Well, that was okay. Now, so we have the firmware in, and now what we just want to do is let's have a first test drive, then we will see how it goes. We will just plug in the 4 pins from here to here. Accordingly, on my blog you will see it on my blog. It's there, everything to everything I have made. Sorry, where it is. Scroll bars. Yeah, this is the circuit, how it connects. So let's pin up the circuit first. Wire up the circuit first. So I'm pausing the video for a while so that I can plug things in just accordingly. Nothing's gonna alter. It's just the same. So previously I was using this circuit with no diodes, no resistors, but it worked to be faulty, so I shifted back and advised people use the new schematic with the full USB VUSB device. Still I'm not using a capacitor. Since I have a capacitor on board, it will compensate the loss, as well as I have capacitors. I have capacitors on board the Arduino, so I'm skipping off the capacitors. Capacitors are necessary for people using breadboard with with bare minimum Arduino, just as a chip of Arduino Atmega 328 chip. So it's for those people, not for Arduino users. So let's pause the video and wire it up. We're back. So we have wired up everything. This is, as you know, the VUSB circuit board, and then to our Arduino. Okay, pin number 2 and 3 to data lines, and VCC to VCC and ground to ground. USB cable. This is our device manager. You can see nothing right now. Alright, let's connect it. So here we have USB-ASP. Can you see that? Okay, if I zoom in, because flash will cause a problem. And okay, so USB-ASP. You can see that now clearly, right? So this is all about the circuit. And yes, see what happens if I touch this. I tried connecting. I don't have something to hold the camera, so I'll have to use my legs. And see what happens if I try to touch this and reconnect. Hi, you see how sensitive the circuit is, even to touch. You have an unrecognized device just because I short circuited it using touch. So this circuit is to be built very carefully, and everything should be considered sensitive. Even values of diodes are critical. Now you see you have back to USB device. Okay, so considering things critical, you should remember even a touch can cause disorientation of the signals. Let's try it once again. Previously I was using a different USB cable, and that was really not a good one, so I decided changing the USB cable. Let's open it and plug it once again. Yeah, it happens to be again. Okay, let's focus back, see what happens. Well, let's focus back to our... Okay, so let's unplug it and replug it. Device detected properly. Well, this is a big issue which you're going to face at start. So remember to build the circuit as neat as possible, as flux free as possible, and as with minimum solder as possible. And see, try to keep the diode values very critically near to the nearest. Resistors are kind of, you can have 38 ohms to 68 ohms. and this pull-up resistor can be around 2.2k to 3k, 4.7k. It doesn't matter for the resistor most of the times. Basically try to keep the things as intact as possible. 68 ohm resistor, 2.2k pull-up resistor, and 3.6 volts in the diodes. That's all. Well, this was about the circuit, and you know, the pin out and pin mapping. Now let's connect it to our host board and program it. We have seen device detected properly. Now let's connect it in program. Let's see what happens now. Well, everything else is wired up. I already have a fade sketch running on, and the device is acting as a USB ASP connected directly to the USB port, and this was the upload cable. We will see to how to upload the firmware. I have unplugged this cable just because lack of VCC and ground pins on the board, so I cannot plug 2 or 3 devices at the same time. I'll have to make another board, or I have to put this on a breadboard. That is gonna be nasty. So keeping it as simple as possible, I have disconnected after uploading the firmware. I will re-upload the firmware and show you how to upload the firmware as well. Well, let's go. This is the new second version of my tutorial, of course. So let's see the programming in action. I'm going to change the. I'm going to change the fade sketch to a blink sketch and then retry it again. Let's illuminate my room properly. You see things are real properly. I have no light. This is my another project. You see this home automated system. This is also one of my projects. If you want to build this, I'm gonna make the open source circuit for that. Well, this is our USB ASP. Fine, ready to roll. Let's close it up. And now Arduino. Let's open Arduino. We will be uploading our sketch directly to Arduino using using a programmer to upload the sketch. You know, there's enough feature in Arduino. If Arduino users know that probably. Sorry. Let the Arduino open up. Quick and fast. So our Arduino is open. It's focused on, and our flash is causing some problems. So I'm going to open up the blink sketch. A little modification in this sketch we are going to incorporate, that is changing pin 13 to pin 9 for our blink purpose. Okay, let's change it as quick as possible because I don't want to waste any time on making big video. Okay, I think it's done. Output is 9, right as 9, make it 0 as 9, high and low, delay between. Okay, fine. So now what we are gonna do, a bit focus on the. Okay, first of all. Okay, now we will first select our programmer as USB ASP. It's already selected as USB ASP. Let's reselect it. And now we are going to upload it using something called upload using programmer. Let's refocus again. Upload using programmer. Wait, what's wrong? Now we hit it. Now the terminal window here is compiling. We'll see it more better way. Wow. Let's do it once again. This beta version of Arduino is really a problem now. It's not good enough. I'll say use the previous version. I'll prefer that. Thank you. AV dude says what? Okay. Okay, now let's do it once again. What's wrong? Wait, let me see. Something is wrong. Okay, USB ASP device cannot be detected. Device manager. Device is present as USB ASP. Oh, it's a problem, man. Let's export this. We'll use another uploading tool where we can export compile binary. Okay, desktop. We'll export this file on desktop. And use some another upload tool. This Arduino is a mess. We have a hex file with bootloader. This is with bootloader, and this is without. This is really just standard one without bootloader. So, where is our extreme burner? That was extreme area burner. This is our another tool. Focus. Well, let's. Oh my God, we are using Atmega 8 on this board. I'm sorry, this was the reason why it was not uploading. I selected 328 chip signature mismatched. Oh, I remembered it now that this board has Atmega 8, the cheapest one. sorry, I'm very sorry. So let's select it Atmega 8 and let's read it. Okay, so the programmer. Something's happened. Okay, see, there's a read back. Cool, it's working. Now let's go and open our hex file. Okay, where is our hex file? It's on desktop, I guess. Really, yeah, it's in Blink folder. So now we're just gonna use I don't think it's gonna work because we have already selected. We compiled it using. See what happened. How did we compile? This is the last configuration. Well, it was Atmega 8. Okay, there was some issue detecting the device. Okay, fine, we compiled it using Atmega 8, so we will just gonna upload this standard build. Now, write it. This is our Blink program. Let's see what happens after the complete write. Cool. Now we have uploaded the Blink sketch. There were some errors and problems occurred, but I think if you use a good, nice and properly soldered shield board, you can make your own PCB in Eagle, or you can make a proto board mounted on top. That'd be a good idea, I guess. So this would be all that will take to make you a USB ASP directly on Arduino. Thank you so much. This is your host Ashish, and it's nice to meet you all. Please subscribe if you want to make me more videos. I think you should subscribe because that will inspire me, and praise the Lord. And most important thing, with the previous version there were some bugs fixed in this one, and the detailed descriptions about the circuit you see has been documented in this video. Well, and previous version I was using a big size Arduino. Now here we have a small size Arduino. I have also modified the pin edge header files for Arduino to make Atmega 32 and Atmega say 16 to be useful in Arduino environment. Well, you can see to that. I'll upload the links in my blog and full descriptions, of course. This was my previous project, and yes, a few more in my. This is my funny. This is my hood. everything I have in here. This is one Swiss Army box. Well, that is all. And as for this TTL cable, you should see somewhere. I think it's really simple. Just connect your Arduino to the board using TX, RX and DTR pins to reset, and VCC ground, of course, to power it up, and upload it. That's quite simple. If you want to see that video, I'm making another video for uploading, because I don't want to integrate this video and make people mess out of it.